Let's take a look at even and odd functions. By definition, f of x is going to be known as an even function if and only if f of negative x is equal to f of x. So what does that mean for us? Well, it means that if I have some x coordinate on the graph, then its y coordinate is going to be f of x. So it'll be right here. What I'm saying is that if I go just as far in the opposite direction, so I'm looking at negative x, its y value will also be the same. It'll be equal to that f of x. So if we move that x closer and say, maybe its y coordinate is here, its opposite will also have the same y coordinate. If we move further away and something out here, then when I look at its opposite, it will also have that same y coordinate. Meaning that when it comes to maybe the graph of a even function, this function that I just made up maybe looks like this. And what we notice about it is the symmetry that it'll have with respect to the y-axis. On the other hand, a function is known as odd if and only if f of negative x is equal to the opposite of f of x. So let's visualize what that means, that if I'm talking about this is where my x is and its y coordinate is up here at f of x, then if I go in the opposite direction just as far, here's where negative x is, then I would also have to go to negative f of x, so the opposite of f of x down here. Just as far, but in the opposite direction. And so if, as we got closer, our x coordinate had an f of x, it was still positive, then on the negative side, it would be just as tall, but in the negative direction. So just like with the even function, there was some symmetry there, we'll also see some symmetry with odd functions. It's just, it'll be a rotational symmetry about the origin instead of being flipped over the y-axis. So how do I determine if a function is even or odd, or maybe neither? And it has to come down to that definition where in both of them we looked at what is f of the opposite of x. So algebraically what I'm going to do is just plug in negative x everywhere there was an x and simplify my function. When I square a negative x, it goes back to being positive. The opposite of negative x is also positive, and then I have a plus 1. Now we have to make that comparison back to our original function. So I want to look at 3x squared plus x plus 1. And my original function, 3x squared minus x plus 1. And I want to know, are these two the same? And obviously they're not, because in my second term, those are opposite. So these are not equal to each other, which means the function is not even. So next, we take a look at that same 3x squared plus x plus 1, that f of negative x, and see if it's equal to the opposite of 3x squared minus x plus 1. And when we do that, that will change the sign of that middle term back to being positive, but then it will make the first term and the last term both negative, which are not the same as what we have on the left side here. So we see that these two are not equal to each other either. That means that f of negative x is not equal to the opposite of f of x. So this function is not odd either. So f of x is neither odd nor even. However, when we look at g of x, let's plug in negative x. So 3 of negative x cubed minus 2 times the opposite of x. And we simplify that to get, well, taking a negative number to the third power, we'll keep it negative, so negative 3x cubed. And the opposite, or negative 2 times negative x is plus 2x. And we're going again to compare it to the original function. We want to see is g of x, or g of the opposite of x, is that equal to g of x? That's what we want to know. And we look, and my g of negative x was 3x to the negative third plus 2x. Is that the same as my original function, 3x cubed minus 2x? And no, they're not. Our signs are not the same. Since they're not equal, this is not even. But let's take a look and see if it's odd. That's where we want to look at g of negative x and compare it to the opposite of g of x. So my g of negative x was negative 3x cubed plus 2x. And the opposite of the original function, 3x cubed minus 2x. When I distribute that negative, I get negative 3x cubed plus 2x. And these two expressions are equal to each other. That means that g of x is odd. And when we look at all the powers, we notice that 3x cubed, that's an odd number, and 2x is 2x to the first. That's also an odd number. So maybe there's something to that if we are only dealing with odd powers, that we'll have an odd function. So what about a function like h of x, where we have 2x to the fourth minus 3x squared plus 5? The only powers I see are even, but I also got that 5 there. It doesn't have an x on it at all. So to check whether it's even or odd, again, we have to plug in the negative x. That'll give me 2 times negative x to the fourth minus 3 times negative x squared plus that 5. Of course, anytime we take a negative number to an even power, it's going to turn positive. So this thing will simplify to 2x to the fourth minus 3x squared plus 5. To see if it's even, we have to compare it to the original function. And what we want to see is h of negative x equal to h of x. So, taking a look at it, my h of negative x was 2x to the fourth minus 3x squared plus 5. And my h of x was 2x to the fourth minus 3x squared plus 5. Since those two things are the same, that means that h is even. So that's how we tell if a function is even or odd.